So now we're beginning to look at another element of fit, and that's the fit between information flow systems, work structures, and what you've done is probably added some new tasks to these task groups. You may not have originally said, we got to teach them how to operate these terminals and that kind of stuff and that kind of stuff. And we've also got to provide the time to operate these terminals. So you may have added some more stuff to your task listing, which is back to the iterative nature of the process. You may need to go back now and say, okay, originally we thought the groups were going to do this, now they're going to do that in addition. That's one consideration. The other, when you come around and looking at reward systems and people systems, reward systems hopefully tie people systems to tasks. You know, in some way or another, they have some influence on getting people to do what they're supposed to do. So that's a kind of a next mechanism, is how can you do that? I was typically kind of one step removed from automated information processing systems, but I got directly involved in fight between an MIS group and a sales group, because for whatever reason, MIS is supposed to be servicing sales, and there was a constant battle between those two units in the quality of the sales, and I mean the quality of the data and everything else. We got to examine it. Really, the goals, the motivations, the everything else of the MIS people were very different from the goals and the motivations and priorities and interests of the sales people. And so you just looked at the incompatibility of the interest and goals and lack of commonality and all that kind of stuff. Then we kind of get back to this integration by planning and goals. We get back to priorities, get back to all of that stuff. So there's definitely, when we look at information flow requirements, there's definitely a human element, which normally has to be taken care of to some degree around people issues, to some degree around reward issues, to some degree around structural issues. In this particular case, they tried to remedy the problem by taking an MIS person and relocating them into sales, and not only one, but several of them. And so they set up a little subunit within sales, and that was supposed to work. But unfortunately, after those people got in there a little while, they began to think like salespeople did, and the fight just resumed and continued. So that's another one of the issues. Another kind of an example at the operating level where the human element is a factor. In a plant that made paper I worked in one time, we made paper towels and toilet tissue, each of them in 4 colors, and each of them, in effect, they had various schedules and everything else. And they got their products from a set of paper machines, and sometimes one paper machine would be running stuff for paper towels, and the other time the machine would be running stuff. So we had an awful lot of stuff. We had hundreds and hundreds of what were called parent rolls, and these are great old big rolls of paper that are taller than my head, stored in acres and acres of warehousing, 16, 17 acres of warehousing for parent roll storage. And the question is, how do you keep up with all that stuff? You know, 4 colors, 2 different product lines coming from common paper machines and being put out there someplace, and you don't want to lose it. You don't know where it is and how old it is and that kind of thing. So anyway, had some people come in, build a beautiful information flow system, so you knew not only where the stuff was, what color it was, what quality it was, when it was run, this, and this, and have that information available to the user system so that they could go out immediately, knew we had X number of rolls of green or pink or white or something or another, and they knew right where it was. Today we're running pink. We need this particular quality, and. Beautiful system. They had it so that people who took it off the paper machine were supposed to punch some stuff into a computer that indicated what it was, and then people who took it to where it was supposed to go had to put something in that says this is where we put it. And then people who took it out was supposed to put something in that says this is what we took, and people who used it were supposed to say this is what we used. So some way or another we had a lot of people involved. Well, obviously, if any one of those people failed to do something that they're supposed to do, then the whole system broke down. That's the human issue that when you're designing information flow systems, you've also got to design in. Now, this can be dealt with to some degree by bounding, to some degree by setting up common responsibilities, some degree by performance measurements, but in some degree, it could even be involved by having these people help you design the system. Because it was a pain in the neck to get down off your truck after you've done this and go to wherever that terminal was and put that stuff in. So you got to figure out some other way so it's not a pain in the neck if you want to do it. So I'm trying to introduce, when we design information systems, do it within the context of all the rest of this stuff. I've seen some systems that really are beautiful. In another case, making diapers, had a lot of stuff coming in the front end of a very high-speed machine. You had polyethylene and what they called dry lap and all sorts of stuff. And other places in the machine, you had cartons and you had glue and you had things feeding in all over the place. We used to account for that monthly, and at the end of the month, you'd find out whether you got a 70% yield or 95% yield on materials used. And then you were properly chastised or praised at the end of the month, but it's too late to do anything about it. So we decided to speed that information flow system up and set up a system so that every time somebody put a reel of polyethylene on the line, they just, in effect, okay, so-and-so it came from such and such a supplier, whatever it was, and they put that in a button and it went someplace. And when they put something else on the line, we knew how many pads we were getting per line on a real-time basis. They had that thing so it had the capability of giving you an hourly or even faster readout on yield. And so instead of waiting for a month, we knew essentially all the time how many diapers we were getting per whatever it was that was coming in the other end of the line. The change at that one plant, just by installing the system, at the time that was the best plant in the operation, they were running about 90% yield. We put that system in and went to 97%. I can't remember how many millions of dollars that saved, but it was powerful because a bad pad goes to the dump or the fuel for the boiler or someplace, but you sure can't sell it on the market. So just the potential of that. But now the issue was that the people on the line themselves benefited from that. Their performance had a heavy effect on yield. Now, if you provide them historical data about their performance, there's not much they can do about it. If you provide them real-time data about their performance, they not only tend to do something about it, but they like it. They like that immediate feedback. So I'm really trying to introduce this issue just around inventory data. This may also help you get some yield or whatever you call them factors. It also may provide some motivation. The caution is don't do it in such a way that it makes it a pain or a punishment for people to do what they got to do to make that system work once you've designed it. Does that make sense? Have you seen problems in that nature? Let me test. I'm talking now essentially about information flow at the operating level, sort of horizontal flow, coming in from the external world to the groups, coming between the groups. Let's take a quick look at information flow requirements so that we fit together the support groups. You had a technical support and you had an administrative support. Just to give another twist on, are you comfortable enough when we talk information flow system design at operating level that you can, and what about the fit question? The system fits those pieces, the needs of the people. Let's look at it in a little bit different vein then. What's the information flow requirement? We'll just use this as a general requirement between what you conceived as your technical support to these various teams plus technical support. And my guess is the way you design that, you've got that group sort of on the organizational boundary, and there's information flow requirements between this group and a lot of external groups. Is that fair? How about taking, which one would be most useful to you to try to illustrate? Any particular one? In other words, this is kind of information flow requirements internal. This would be information flow requirements external, with the thought being, could we design a system to be sure that information flow occurs? Internal? Let's list some kinds of information that needs to flow then. We'll brainstorm a list. Pardon?
Specs. Process changes. New product. quality, technical quality.
That's two kinds, or a special kind, but various. This is information about the quality of the product. Okay. Other?
Maintenance requirements.
Maintenance requirements, that sounds like that's a arrow coming in here, and then out of that goes
It may be information out around.
out, in, or in. Okay. Let's go ahead and put a double arrow, because essentially all of these are double arrow, I'm guessing, aren't they? Both directions. Looking at one of these, which one would be most helpful just to explore in a little bit of depth? We just want to, let's quickly design an information flow system for some element. Process changes. Is that okay? We're going to highlight it. What's the kind of, a little more detail about the kind of information that needs to flow relative to process changes? Yeah, what, I guess, some idea of, pardon?
New technology, available new technology.
Like automation of formerly manual tasks.
Recognize needs on the shop floor.
By that, what do they need help on?
Problems. Problem solving.
Can we define what process change means to the person put it up there?
I put it up, I was thinking of alterations in how a module is built.
That's engineering change order, but we're talking about broader
Well,
process change
no,
also.
not just that, not just a change order in that particular module, but rather maybe a whole group of modules or a module build operation.
We may be having trouble law, so somehow the process determines
Okay.
that we should be running wave at 190 degrees instead of 220 degrees or whatever.
Engineering changes, so forth. Again, in the interest, yes. Pardon? But documentation, again, I guess information that you document comes from someplace and then probably goes someplace, and so that itself could even be a separate system.
Test procedures?
Test procedures. Let's stay with this. Here, the question is going to be sort of which of these kinds of information would best flow on a face-to-face basis, which would be, something you'd manually, paper basis, and which maybe on some kind of an automated basis. Let's just kind of look at those three possible means. Those are technologies from getting information from here to there. Any of these that obviously probably are going to happen sort of on a face-to-face basis.
Usually ECOs, the engineering changes happen on a verbal level first.
Okay. Other kind of face-to-face,
Problems?
easier and faster and everything else to communicate verbally than put in writing and so forth.
I'd have to disagree on the engineering changes. That's usually pretty structured. Yeah, pretty written.
Okay, well, put a question mark there. Let's, just to illustrate the point I'm getting ready to do, then let's design an information flow system to ensure that the information relative to process problem flows where it's supposed to flow, and you do with it, you decide or use it, whatever it is, the way it's supposed to be used against this model. How would you do that? What's a mechanism for ensuring that kind of information flow from a support group to an operating unit or vice versa? Got some ideas?
First thought was to put any of those boards, have as one of their tasks that interface.
Okay. Was that a part of your design element already? Had you allowed for that? Was that, would it be exchanged during board meetings? Or would that be on your agenda every time that you have the so-called technical board meeting that will be discussed, or what? Yes?
Get the people most directly involved with the problem and the people most directly involved with the solution. In other words, cut out as many middle steps in the conversation.
Yeah, I hear a principle. Now, how about a design to implement that principle? Yes, Joe?
How about some kind of stopgap so change can't be implemented until all assigned people from the team sign off on it, and it's agreed to.
We've got a couple of elements. We're saying here's some possible design alternatives. One of them was suggested during, what do you call those groups? Anyway, the
Plant-wide board?
board group. Okay, so one of them is in board meetings on a face-to-face basis. That information could flow. Another one would be some kind of a sign-off system.
Engineers just walking around the shop floor with some.
Okay, it could just be, but planned and so forth. Let's just say planned tours or something.
Measure them on the back of the building.
That's more the problem that I'm thinking of, nothing that could wait a week to solve.
This is like it's got to be done real quick.
Yeah, immediate productive problem.
Okay, now what's the system? Do you need a system? Now, a lot of this stuff occurs naturally. For goodness sakes, don't design something that's going to happen anyway.
Question.
We're trying to make stuff happen that's not going to happen.
Yeah, question, you make it, I wasn't here or don't remember descriptions about who's on the team, the kind
Okay.
of structure and organization, I'm not sure, because maybe this one pushes you back to where each team has an engineering person who's on it, and now you've moved into a face-to-face.
Hey, you preempted me. That was going to be my next question. How can you do this as cheaply as possible and as quickly?
Staying close to the hand, it was get the people's solutions.
Is that right?
closer to the people's problems.
So one mechanism would be to really just move the fixer in here. Is that right? So that it occurs in the information flows during team meetings and face-to-face and all that stuff. That's a mechanism. That's a design.
And that's kind of showing where you, while you're addressing the information system, you may get pushed back into the structure,
Okay.
of the organizational work.
Okay, now that may take care of some of it. Are there other kinds of issues that may need another mechanism? Would you possibly need to have some of that stuff dealt with in board meetings?
Yeah, if you were introducing a technology change, that was going to change every single operating room.
Okay. So we're identifying that we've got, even though we kind of classified it as the same kind of data, you can handle part of it here, but you can also handle part of it here. Now let's kind of examine what about some kind of a sign-off system. We're looking for, again, cost effectiveness, workability and all that, but as a design for causing this to happen, would you want to do that?
Could you repeat that? I'm a little lost here.
I'm not sure what was meant, but would you want to use that as a design element in this information flow?
What is sign up?
Well, it means that they agree with the team that they realize the change is coming and agree with the change, whatever the change happens to be.
Well, I think maybe this was just dealing, as I understand it, day-by-day problems rather than changes.
That would be where you have a sign off if the engineer were not part of the operating group. They were consultant to the operating group, so the
Okay.
engineer came in and made some suggestions, and the team could decide whether or not they wanted to follow the level of expertise.
So that's a mechanism that could be used both for dealing with engineering changes and possibly with day-by-day problems. Yes?
Another piece of that would be to document, to have some documentation system, document the problem, the solution, and that get distributed to appropriate other places in the plant.
Okay. So some kind of documentation. Just another war story. I saw that work beautifully in a paper plant. The technology, they were putting in a new, what they call a wet end from Sweden, and it had never been used by the company before. And just like all stuff, it had to be debugged, and there were a lot of unknowns about it. So they created what they call a learning from experience approach to handling this kind of information flow. They put flip charts in the control rooms, and they followed a model that said every time something happened, then they listed what happened, and then when they what was the effect. You know, this happened, it made this thing happen. And then they diagnosed it, so they would analyze, and when they found out, then they would say why it happened. And then they'd come on around, and out of that began to develop some general, some general ways of solving the thing. So then they would kind of generalize or theorize, is this thing likely to happen again frequently enough that we need to change the process or the product or the whatever in order to keep it under control? And then they just cycled that. And I mean, somebody was talking about how much chart paper you use, but this was like a day-by-day running account of what happened, what they did about it, why did it happen, and what do they think about the probability of happening again, how could they control it, how could they deal with it. And the effect on bringing that process under control was just amazing, because then these raw data got transferred into some engineering manuals or whatever they had. You know, they had a pretty heavy file of stuff that ultimately they were pretty well kept up to date, but the crew itself did it. The crew was, in effect, they were the ones that did all that stuff. The other thing was information flow then across time boundaries. This was 7 days a week and had 4 different crews operating out of the same control room on different blocks of time. So this sort of told the crew that left on Saturday and didn't come back until the next Thursday, they could go back and flip through that, okay, here's what happened. And so the information transfer power of that kind of a mechanism, this is a system, it was designed, was really important in terms of getting that system on the line. So just, they call that something learned from experience or something or other, but that was their mechanism they used for handling processing problems. That was pretty cheap. It didn't cost much. Later on they did have to type it, somebody had to type it, the summaries, but got enough, again, trying to look at, we're looking now, examining kind of one piece at a time, information flow requirements between your operating groups, now looking at some information flow requirements between operating and support. I want to encourage you to say that there are many ways of doing it. The general criteria are do it the most efficient and effective way you can. I had one reaction to sign-off systems. I've seen some amount of reluctance and some amount of whatever. So from a human standpoint, if they've got any punishment potential, or if anybody could get hung because they did or didn't sign off, these types of information flow systems might break down. So, pardon?
Also could be slow.
I just want to encourage you, though, to look at right on the speed, the efficiency, the human element, the possible impact of what you design on the way people use it at all levels.